Hello and welcome to the Low Code Cafe. I am Dale Warner, Head of Support for Plant and App, and this is the episode number 195 for March 25th, 2026. Today we're going to be talking about improving SQL join performance or even just SQL performance. Originally scheduled to be with external systems, and we'll focus on that, but I'll explain a little bit more about why I've crossed that off as we get into it. But this is a technical session. We're going to be talking about improving performance and also some other technical topics and things that I hope that you'll enjoy and be able to put to use in your projects. This is an event that we do one Wednesday a month, this hour, 10 a.m. Central Time, where we get together and talk about what's going on with our product, doing updates, doing demonstrations, but most of all, we're spending time on hands-on coding kinds of topics, technical topics. We record all of these and put them on YouTube. You can get to those youtube.com/plantandapp, and we encourage you to subscribe so that you know when we put in new episodes. Today, you'll hear from me and from me again. We'll be doing a little bit of from the trenches of support, some things that we've learned and other people have been asking about on our support channel, and then we'll spend most of our time on hands-on and low coding. We do ask you to engage with us. So there is a chat window, there's the question and answer session, all those tools within within Zoom that you can use to engage with us. As I mentioned, we do this one Wednesday a month, usually the last Wednesday. Sometimes the schedule changes, so this next month, April 22nd, should be on your calendar for the next one. There's a schedule conflict for the last Wednesday of the month, but we'll do it on the 22nd. All right, so here we go, into the trenches of support. First thing we like to talk about is hot fixes. So we have two versions that are currently within our support window. Version 1.27 was released in June of 2025, and our standard support puts that into June of 2026. So a few more months that's active on that one. And then our current version is 1.28, released in January of this year. So support for that will go through January of 2027. Yeah, I didn't get into hot fixes. I want to do that. I have a system here that has the hot fixes that are being released to version 1.28. Nothing has been installed except since we've gotten together last. But you can do that. The way that you install hotfixes is go to the Updates tab of your system, make sure that you're backed up, both your database and your file system before you do this. But when you check for updates, you'll see all of the different hotfixes. We release them a batch, usually once a week. Some weeks we skip. And when you install one, you install all the older ones as well. So in this case, we haven't installed them since the February 17 one. When you select it, you'll see all the things that are going to get installed, lots and lots, and you can see if you hover over this eye icon, you can see exactly what's there. But if you want to install it, and it's all or nothing, you click Prepare Update and check the read and check the boxes, and then you can start the installation, and all the things listed will install. This is your system will be offline for the duration of that. People won't be able to use it until the install completes. And again, you really should have a backup. So I'm going to start this. We're not going to sit and wait on it, but you can see the progress as it goes on here. So I'm going to move that out of the way. And continue with my presentation here, which is to say, next thing, we have some new support features that you'll see when you're entering a ticket with us, starting possibly as soon as tomorrow, just letting you know that you can get paid assistance in a couple of different ways. So one is if you're entering a ticket on a system that is outside of the support window I was just talking about. So at this point, anything version 1.26 or earlier, or even outside of the 126 or earlier, that you'll see the option to get help from our team to help you do upgrade if you want it. And if you choose that option, we'll reach out to you and schedule it with you. And depending on whether you're hosted with us, by the way, we do hosting. We'd be happy to host your site as well. But whether we do it hosting or whether we work with you in the on-premise scenario to help you through the upgrade, but we're happy to help with that. And then if you've experienced support, we do support is primarily by email. But if you want to achieve a higher level of support where we work directly with you and perhaps get on a call and get on things more on your schedule than on ours, then you'll see a new option for paid hands-on support, and we'll reach out with you to connect on details. But that's just an option if you have something that you want to accelerate and get solved immediately. So watch your inbox. There should get a mail from us for that coming up quickly. So now more from the trenches. We had a support case that came up that pointed out that there are some things that you can do in automation that potentially could cause some performance, some resource spikes, using up your CPU, using up your memory. And I just wanted to kind of point out the issue, point out the easy solutions to that. So we provide a variety of tools. There's skip if running. There is overlapping trigger times that you're in control of, and then just a quick reminder to use the queue pattern. So we'll get into all those in a moment, but I have a system here that's pretty much empty. Going to take a look at the automation, and I've set up two jobs, and we're just going to talk about job number one, the wait one job here. And if we look at it, it's a very simple job. I've set it up to run every second, and I'm going to turn off the skip if running thing so that you can see this at work. And I set it up as a workflow that doesn't that just executes a delay. So the only thing this job does is wait around 10 seconds and then end. But it's going to run every 10 seconds. And so what you'll see if I enable this job and open it up is that when it starts running, we're going to see our thread count jump up. So if you haven't thought about this before, there is this concept of threads. Uh, the automation system can run many things simultaneously. And if you set up a job to run frequently and the last job hasn't completed, then the next one will start up and they'll both be running, and depending on how you configure that and how long they run, you might get as many as 10 running at one time. So if you do this, if you set it up this way, whether on purpose or accidentally, you can get into a situation where if those jobs are very intensive, that they'll slow your system to a crawl when that event happens. And so that's one thing that you should avoid. So notice that 10 is the maximum threads we currently support. Notice that if I turn this off, that eventually you'll see after 10 seconds or so, all those individual jobs will quit and then will no longer be running. I'm going to edit the job and just with one change, do skip if running, and we'll start it up again. And what you'll see now is that we'll only get one thread running. That even though the job runs every 1 second, the first thing that it does is figure out that the prior job is still running and it won't run again. So that keeps the job from That's one of the tools that you can use, skip if running, to make sure that you don't get a bunch of overlapping jobs. In the case of the client that kind of got this started, the situation was that they had about 10 jobs defined, and they were all of trigger type repeat daily and was repeating every day. And the time was set to 12 a.m. Now, by the way, I'll just point out this is UTC time, so it will adjust based on, I mean, UTC time is uh, obviously a defined time, and it will translate to something in your local time. But if you have 10 jobs that are all set up to run it at 12 a.m. UTC, they're all going to kick off at once. And because there's lots of threads, they might literally all run at one time. So one of your strategies would be to stagger the start times of things and to think about, yes, you want things to run once a day. Uh, if it can run in the middle of your nighttime, you should do the translation of UTC and set it up for 2 in the morning, and perhaps you set up something for 2 in the morning and something else for 2:15 and like that. And so you don't, number one, you shift it to off hours if you can, and number two, you prevent them from doubling up and running at the same time. Now, skip if running only refers to the same job, the same automation running. So it doesn't, if you have 10 different jobs, skip if running doesn't help you um, keep them from competing at the same time. Anyway, your server may have plenty of resources and it may run just fine when all of your jobs run at once, but choosing to select non-overlapping trigger times is one way that you can help with that. By the way, if you set up something to run every 1 minute or every 10 minutes, the mechanism behind that actually starts it at the minute and 0 seconds. So it's not like a random 10 minutes from the last time it ran. It'll start all of your every 1 minute jobs at exactly the top of the minute. And so that's another thing that you should just be aware of. And then I'm only going to do it as a mention today, but another thing that you can do to prevent resource spikes would be to use the queue pattern, which is where you create your own queue, a table, for example, of things that need to be done, and then work on one or two of them, or so some limited number at a time, so that if your site gets very, very busy, if you're responding dynamically without a queue, then um, all the work gets done as users are hitting the submit button or interacting with your site. If you, instead of working on that immediately, if you put them in a queue, then an automation can run and take the first thing in the queue and get it done and then go on. And so that ends up kind of single threading all of those um, uh, tasks that you need to get done, and instead of it being at the user's discretion, it happens one at a time and prevents overflowing your resources. So those are just some things that you can take advantage of if you want to. Just by in our client's case, just by adjusting the start times, the performance issues were resolved. They were just seeing a really sluggish system at 7 in the morning every day, and there was a definite reason for that. Great. Um, there is there is a website where we put a lot of examples. It's called campfire.plantanapp.com, and this is a website that goes along with our other weekly event, Fridays at 10 a.m. Central Time, where we talk about the techniques that and very practical things interactively, talk about them in our Campfire meeting. But then this website is a place where we record all of those, and so there's a new contribution there. So I want to show off a little bit. We had a client ask about wanting to do speech to text together with our Forms product, and turned out to be something that's somebody on our team was able to provide an example of, and I have now posted it out here on our Campfire website. But once you start it up, as you talk, the text in the text box begins to fill in, and it's very interactive. It continues until you tell it to stop. This is a pretty simple JavaScript implementation, and just wanted you to know that it was out here, that and 100 other techniques that might be useful to you, that you can go view the contributions and then shop for techniques. And lots of them are documented right on the page, how to use them and what they're for. Some of them are just, you have to follow along with the examples, and you might need to contact support to get credentials to be able to access this if you're not already. But just wanted you to know that that one was out there. Okay, continuing on. Our encouragement to engage in low-code Campfire. We do that every week, almost every week, 50 or so weeks out of the year. And it's a great group, and it's a great place to get problem solved. So do jump in and engage with us on that one. I'm going to put these links on the clipboard, or on the chat rather. So if you want to know how to um, be part of the low-code Campfire, where to find our recordings, how to get to our community portal, which is a great place to also get questions answered, not only by us, but by the community, and give feedback. That feedback form is for feedback, anything that you want to let us know about this webinar or what you'd like to see in future webinars. All right. Now to the exciting stuff. Improving SQL join performance with external systems. We can debate that one, but here's where we're going to go today. The idea is that we're going to have a test scenario where we have an external system, like us. In our case, we'll be talking about a CRM system that has many, many records, but it's an external system, so we don't have control over the way the database, the shape of the keys, the unique keys in that database. We just have to use it as it is. And then we're going to have a plant and app database table that we're going to join that to, and we're going to look at the performance of that and the issues behind it. So the scenario that I'm going to work through is that we'll simulate having that external system by creating a CRM contacts table in our database. Again, it's just a simulation, but we'll put 10,000 records into it. And in that case, the contact ID is going to be the unique key that is in that record, and it's going to be defined as a character 12 kind of a field, 12 characters in length. Then we're going to connect that to a plant and app entity table, the contact history, and we're going to put 1,000,000 records in that, 100 records for each contact. So it's simulating having a contact, and then we're maintaining the history or whatever we want to maintain in Plant and App, and yet we're integrating to the external system. Plant and App defines text fields, and that's what we're going to use as a very specific SQL type that is nvar. How do you pronounce this? Nvarchar, we'll say 450 wide. It's just a general purpose field type. And so there's a little bit of a mismatch between character 12, character 450. And so that's the scenario we're going to set up, and we're going to generate those tables by doing some SQL scripts, and then we'll do some testing on it. So that's the scenario, and here we go. In my we'll be doing a lot of work in SQL console, so that's where we're going to start. And I'm just going to demonstrate that this is an empty or a normal plant and app database. So we have lots of core platform tables. But if I do a search, there's no CRM tables, and we'll also see there's no app tables yet, which is where when we create the entity, where that'll go. So we have an empty vessel here, and we're going to start filling it up. The first thing we're going to do is again simulate this. Ah, copy and paste here, a little bit difficult. We're going to simulate a table that is going to be our external database or in CRM context. So we're going to use SQL to create a table. It's going to have contact ID, first name, last name, status, and it's the main thing to point out here is that this is a character 12 kind of a setup. So we'll run that and that will get it created. We can refresh and prove that it gets created. Looking at expanding out DBO here, that now when we search for CRM, we have CRM contacts. We can open it up and see that the fields are defined as we've specified. So the next thing that I want to do here is to fill that up. So I have, together with some help from AI, I've created a SQL statement that will put a lot of data into this in a hurry. It's empty, so we don't need to delete anything at this point. But we're going to create 10,000 records here that is going to have test data we're going to insert into CRM contacts, and they're going to have first name values and last name values somewhat at random. And so we're going to go ahead and run that. And once we do that, we can use our interactive thing here to create a select. And I'm going to just ask for a few. But we can see now that we have records that look like it has a contact ID, first name, last name, prospect. So generated a lot of data in a hurry. And I'm just going to grab one of these keys. We're going to need it in a minute, so I'm going to put that on my clipboard. All right. So this is the simulation of the external database, something that if you're integrating with some other CRM system, you might not have any control over, but at least we can simulate it. The next thing, and I want to avoid doing a lot of typing today, so I am going to just import a predefined entity, but I'll do it here, and you can see it. This entity is the contact history entity, and let's take a look at it. So it's going to be called contact history, plural contact histories, going to display right on the main menu. And the properties that are involved, aside from the system properties, are we have a contact ID. And notice I'm intentionally not making it required, searchable, filterable, sortable. It's none of those are checked, and it's important to know I'm doing that this way because I'm avoiding creating an index. So if you are on the current version of Plantain app, you'll see that this has the statement a database index is created automatically if you choose sortable. Same thing happens if you choose filterable. So we're trying, the platform, the Plantain app platform is trying to give you the best defaults it possibly can and do for you, build something that's efficient. But I'm intentionally building this as inefficient just so we can demonstrate. Then it's going to have an interaction date and a notes. And so this is our entity, and it's been created for us. If we look in the preview of the site, we can see this entity has been created with some, it's got no data in it, but we have a screen that we can look at when we do have data. All right. Back to SQL console. I have another handy query here that is going to be used to populate this. And so this is going to create 100 items, one for every CRM contact. So if we multiply that by 10,000, this is going to give us 1 million records. So I'm just going to let that run Runs pretty quick. I made a mistake yesterday while I was practicing for this and managed to try to create 10 million records, or I don't know, maybe even 100 million records, and somehow I managed to set up a big long delay. Could uh, The scale got way beyond the capacity of my server. Anyway, always something fun. Hopefully, I don't do it today in this demo. So now what we have is for we can see we have a million records, and so for every contact ID, there is a record with kind of a random date and some. I didn't even do random notes. It's all the same, but we have a million records. And so if we were to do a join query from one to the other, we'll be able to get 100 records per contact. So hopefully that's a setup makes sense. So let's see what we can do with this. I've got another sample query where we're going to start to use this, and I'll just paste it in here. This is just a select query. It says, I want to get everything from my contact history, CH, and join it together with my contact, and I want to do it for a particular ID. Remember, I said I was going to need the ID here. And so when we run this query, we get 100 records, and the information is all joined together. So we've demonstrated that the external system, the quote air quote external system, can be joined to our contact history, and we can get the impact that we want, and see all of our different information with a join query. So this is where we're going to jump off and get into performance. Hopefully I didn't chew up too much time with that. Um, let's see if I can, yeah, that's the better slide. So now that we're up to this point where we've got this scenario, my hypothesis, and I tried very, very hard to prove this, but was that there was going to be a problem when we joined from a character width of 12 to a character width of 450, and that we could get improved performance by solving that with a mapping table. And that's the false pretenses I brought you here on when I sent out the email. But it turns out that SQL is smarter than I am, and maybe smarter than AI is as well. If you if you're looking for performance hints from AI, and you describe the tables that are involved and provide a SQL statement, AI will um, do an analysis and say, hey, but wait, you've got 12 characters in this table joining to a 450 there, and you're getting an implicit conversion, and this is a performance problem. Um, but when you and so given that, you're going to spend some time chasing, hey, if I fix this problem, 12, getting 12 to 12 instead of 12 to 450 or whatever it is in your case, I'm looking for that performance improvement. What I found in my testing is that the performance is improvement is negligible, and that warning from AI to try and improve that, it's a good it's a good thing in practice, but there is it's not the main performance problem. So we'll be talking about that a little bit more, but not we're not going to be focusing on it. Going back to the nature of the problem again, the 450 part is pretty consistent. When you create a entity in Plant an App and choose text, it automatically creates it as a 450 characters wide, and that can't be changed. We simplify when you do an entity, you choose a data type, Plant an App chooses a corresponding SQL characteristic, 450 characters wide, for example. Large text is a text field that's of an unlimited length. And so we try to insulate you from a lot of that, but it also takes away some choices. So you can't tell it that you want it to be a 12 character field, or you can't add a 12 character field. We don't recommend that you add uh, properties to your tables to make that match up. But it turns out it's the smallest part of the problem. So this was the image that I sent to you, kind of pointing out that 12 versus 450, that we do get implicit conversions, and we do. But when you dive deep into it, it turns out that SQL figures out a better, easier way anyway, and kind of insulates you from that problem. So what I was going to propose, what we understood the right answer to be, was to put a map table in the middle to say I'm going to match 12 to 12. So we're going to have a contact ID map table that has the contact ID in it, and then the ID of the contact history, so that it would be all indexed joins that all of the same shape. And again, that's what I found out really didn't make any difference. The findings that I got into was that the mapping table doesn't consistently improve performance. I was looking for a way to say, just do this, problem solved, but that's not what happens. If it's a very small result set, there's no difference between doing a direct join in this 12 to 450 versus doing a mapping table that has 12 to 12. Small sets, no meaningful difference. Medium sets returning 100 or 1,000 rows on a million record database, there was a slight improvement was possible. And then large, it can actually be worse. So the conclusion that we came to, again, is that there wasn't any universal benefit to the mapping table approach. So my pivot today, and I had a whole table of statistics. I'll leave it up there for just a second so that you can come back and look at it on replay. But the idea is that this shows all the CPU times and elapsed times, and really wasn't much help. So anyway, that'll be there in replay if you want to study it in depth. Um, and so where we got to is, instead of the structural workaround like adding a mapping table, it really the pivot for today's talk is, let's work on measuring performance using indexes and doing query tuning and leveraging AI to help you do those things. So hopefully what you're going to walk away from this today is some tools. So let's look at the tools. Let's go back to our SQL query. I've got this query that we have developed. And take away the order by but just run it again here. And so this within our SQL console shows that you can get a result, but I'm going to do this same thing. I'm going to move over to SQL Server Management Studio, and I already have the database open. I'm going to refresh my tables here so we can see, and I'm filtering, right? I've got a filter present that has here's all of the tables that are present. I'm going to filter just for um, tables that have contact in them so that we can just focus in on the ones we care about today. So we have the contact history, the CRM contacts. If we put that same query into SQL Server Management Studio and run it, we'll get the same 100 rows back. So that's perfectly expected. So now we get into what can we do for performance. There's there's a couple, and I'm just going to copy paste again. This is the similar query here. Let me get it. In SQL Server Management Studio, you can do set statistics IO on and set statistics time on, and that's going to give more information. Before I run this, I'll look at the messages from the last time. It just tells me 100 rows affected. But if I run this same thing again and look at the messages, it's going to give us some clue about what we accomplished, what SQL had to do to accomplish this effort, and showing you some timings. And then there's another one I'm going to do when you're playing with changing the way that you're doing, you're asking SQL to do the work, like adding indexes and things. You can add option recompile, and this tells it to don't rely on any plans that you've come up with in the past, but rather uh, reevaluate and come up with a new plan. So this is just going to help us as we change the conditions of the test to not rely on what it did the last time. So when we execute this, what we get is that, and I'll give you a little bit about how to read this. The fact that there are 13,751 logical reads, it's a clue that SQL had to walk through this entire table on contact history to find the things. And then it did some logical reads on the CRM contacts. And then we get CPU time that it took and elapsed time that it took. So this kind of gives us a baseline of how long this query runs. And if we start changing conditions, maybe we can uh, validate that we've improved it. So I'm going to execute this again a couple times just to give us our baseline. So we see 141, 163, and 125, 132. I'm going to capture that just for comparison so that uh, we can look at it after we've made some changes. I'll put that aside. We'll come back to it. So I'm going to drop away from my SQL Server Management Studio and back to Plantain App and fix the problem that I uh, that we kind of intentionally inflicted on ourselves. We look at the contact history and we make this sortable. We're going to get an index. Now, I'm not saving this yet. I want to illustrate clearly what Plantain App is doing for us. If we look at this app contact history and look at indexes, we'll see the indexes that Plantain App has already created for us automatically. And it includes these create by dates, create by information, modified information. The interaction date has a index on it, and the notes has an index on it, and contact history. This is the primary key, the ID is also has an index. So we're trying to do some things for you automatically. When we save this change to make contact ID sortable, behind the scenes in Plantain App, it's adding an index. If we refresh these indexes, we'll see now there's one for contact ID. So you doing things on the entity level in Plantain App is getting us to do some things. Since you told us that you want this to be sortable in this case, we said, then it's a good idea for us to add an index. So that's the only change that we've made. We've changed the entity, got Plantain App to add an index. And so now if we run this same query, um, and look at the messages, we can now see that the CPU time has dropped to 0 and the elapsed time has dropped to 22. So that's a pretty good change relative one to another. So illustration one, having indexes on things saves time and or can save time as SQL decides what to do um, with your query. And the defaults that Plantain App has provided can help. Um, I wish that I hadn't eliminated that because the other thing I pointed out earlier that these logical reads, it was said 13,000 and now that dropped from 13,000 down to 319. So the index all improved what kind of reads had to take place. Okay. Um, so the let's do let me illustrate the next thing that is a tool. And by the way, I'm a neophyte at SQL performance tuning. I'm not holding myself out to be an expert, but I am showing you at least where some of these tools are. So these statistics are generating this information, which gives you a handle to at least see what's going on. The other one is if you type Control M within SQL Server Management Studio, tells it to generate to display the execution plan. And so if I execute this now, in addition to getting the results and the messages, I also get an execution plan. And so SQL is showing us how it accomplished what we've asked it to do. And just at a high level, you can see that this talks about has a 98%, and so it's spending 98% of its time doing this particular lookup. And so if you're trying to figure out what's costing you in your query, you can look for the where the most amount of time is being spent and how SQL is doing it. So now on to how can I use AI to help me with this? Um, if you, um, if I take this query, I'm going to tell AI all about the things that I'm trying to get accomplished here. So I have an AI open and I'm not going to give it much explanation. I'm just going to, here's my query and uh, here are the messages. So I'm going to copy the messages that get done. And AI won't be able to help itself. It's going to explain to me what it is that, oh, yeah, it got it. Um, and so it's going to explain the results that you're getting. And if we had done this on the non-indexed, it would have said, "Hey, it looks like you're scanning the entire contact history table, and you really need an index there." Um, So it's telling us what it thinks. 319 pages to return 100 rows, and maybe it thinks that a different index might help. Um, it's telling us that CRM contacts access is perfect, and then explaining the this is more about latency, more about just the time it takes to do things, and there isn't necessarily something to fix there. Um, and it's recommending that we have an index on that you might create an index, and it's actually telling us exactly what index to try to create in order to improve things. So this is going to get me to a topic that if you're doing this kind of tuning, you um, probably should understand what is permissible within Plant and App. And so I'm going to look at our entities documentation. And there's a topic out here, recent topic, understanding custom index behavior. And it's going to tell you when you can, and actually I'll put this on the clipboard here. But this is going to tell you what will happen if you decide that you want to add a custom index. We do support adding custom indexes, um, and um, what happens if you do that. So there's if you rename an index field, it's fine. If you edit data or adding sortable or filterable, all these different things work just fine if you have a custom index in place. But there's an important limitation that you should just be aware of that uh, if you decide to remove a table, I mean, when you put an index in, you kind of take responsibility for it, and so you might have uh, to remove an index in order to get to prevent errors when you're trying to remove if you're trying to delete the field. If you remove the index, then the delete will work just fine. But so short version of that is you can add indexes and not run into trouble. You just take on a little bit of responsibility. All right. So that's that. So um, if you want to take a recommendation of an AI, or if you're a SQL tuning expert and you come up with, let's try this, you can add an index, and I'm going to do that and see if it has any impact on my scenario. Let me find my SQL Server Management Studio. I'm going to run this a couple of times just to validate what uh, there's not a lot to be saved here on this particular one because of it's running with zero CPU and just a little bit of elapsed time. Um, Maybe before running this uh, suggestion that AI came up with, I'm going to change my where clause a little bit to get it to do a little bit more work. I think I might have coded this correctly. I'm going to run just this part of it. Yeah, so this is going to give me uh, 10 IDs instead of just one. And so now if I could type, this will do a little bit more work. Maybe we'll be able to illustrate performance things a little bit better. So we're still down at a very efficient query. Let's do 100 of these. And so now we're returning 10,000 rows, and we're getting a little CPU time and a little elapsed time. So 469, let's see if that's somewhat consistent. Yeah, we're getting 400 milliseconds of elapsed time every time. So this is going to give us now something that we can try to improve. So going back to the suggestion that AI had for us, we can add an index. We can delete it if it doesn't do anything for us, but let's execute this and add it on. And now back to our query. And again, because we have option recompile, it's going to stop and think about the fact that we've added this new index here. Uh, this is the one we just added. So let's see what happens. We execute this now, and now our CPU time has dropped down to 0 again. Let's run it a couple more times. And 31. So we got a pretty significant reduction in both CPU and elapsed time just by taking the suggestion of the AI engine. Okay. Um, so there's another cool thing that I wanted to show you. We see this execution plan, and um, going from, let's get a little bit more work from AI. So we're going to tell AI all about what we've done so we can get more recommendations. By telling it the new query so it understands that I'm pulling more records, we can tell it the messages. And so it'll understand what to do with this. And so um, let's see what it says. And so it's telling us all about the behavior and what it thinks uh, possibility that we might do. But rather than making further performance enhancements, what I wanted to, possibly the last thing I want to show you about this, is that the AI can also understand the execution plan and do stuff with it. So if we grab this as an image, even if we don't understand it, we can, I'm going to save this image. We can add it into our conversation. So it's like having a SQL expert to be able to ask questions of. So you get a nice explanation from that. And then continue your uh, continue your tuning. So again, where we end up going today was changing the focus to measuring performance, being able to understand what kind of CPU and reads and execution time are going on, using indexes to tune. You can also tune your queries. There's ways within SQL Server Management Studio to look up what expensive queries are going on. So if you're trying to tune your site, and I think that's trying to make sure if I can. Well, I don't know. I think I can illustrate that. Um, there's an activity monitor at the database level, and this is a place where you can get um, recent expensive queries. So this might be a place to try to find things that are taking a long time and then deciding to do analysis on them. Um, anyway, and so then using AI or your own or other tools to be able to figure out ways to improve. Um, I will say I have once long ago, I got into a SQL tuning experiment and I added a bunch of indexes and managed to bring a system to its knees. So don't every index that you add some overhead to the database server. You're going to want to add things that are meaningful in your circumstance and not just arbitrarily add indexes on everything and hope that SQL can do it. So be aware of that warning. Um, this slide just kind of illustrates exactly what we saw today. But this is when I did my preparation. So the scan count went down from 13,753 to 3,000, and the elapsed or CPU time dropped dramatically as well. So there's definitely savings that can be had. Um, and then again, um, I spent a lot of time chasing the dream of adding of solving the data type mismatch problem, and that didn't and didn't turn out to be universally better. There are situations where that is better, and I'll point out that the documentation under that same area that we were looking at under entities in the documentation. There is a description about how to do mapping tables, and uh, if you want to try that for a particular situation you're in, if you're seeing that you're getting a strong recommendation that would help, you can certainly try it. And it's documented, but I'll probably be modifying that document to say that it's less of a guaranteed solution. So real solution, measurement-driven optimizations. This is a great place for questions if you have any. And other than that, that's everything that I've prepared for you today. I'll let you out of class 5 minutes earlier if there aren't any questions, but glad that you joined us. Also, letting you know, I'm stalling a little bit to give you a chance to find the question window if you want to ask one. Letting you know that we'll probably take up this and anything else that you want to talk about in the low-code campfire coming up in 2 days, this same hour. So sign up for that, and we'll get into it. And maybe I suspect we have some people that uh, regularly attend that call that understand SQL tuning and the performance issues and techniques that they've used to both find and improve their systems. And so there might be some additional tips from our community. Since there are no questions, we'll save any of those till Friday. Come ask them then. Thanks for joining, and we will see you next time.